electrolysis and the basic concept and how it works, featuring the electrolysis of lead bromide. And this is the things that you need to know for GCSE chemistry. By the way, this video isn't going to involve the equations, it's just going to simply explain the concept in as simple of a way as possible so that you can understand how electrolysis works, in this case with lead bromide. So, electrolysis, this literally just means splitting up by using electricity. Okay, so electrolysis, it kind of sounds like electricity, right? It's just the splitting up of ionic compounds using electricity. And that's exactly what it is. It's just the splitting up, more specifically, the separating of ionic compounds by passing electric current through it. So, splitting of ionic compounds. By the way, if you don't know what ionic compounds are, watch my video on ionic bonding. Ionic compounds are the things that are formed through ionic bonding. So by ionic bonding. Remember, ionic bonding is between metals and non-metals. Okay? So that's basically the definition of electrolysis and what really happens. Let's look at how it works now. And to do that, let's look at the equipment involved. Now, by the way, you need to know the equipment involved. This is something that you have to know for your GCSE exams, and you might be asked to draw the equipment, and you may need to annotate the equipment too. So this, I know my drawing's not that good, but this is a beaker. And within it, it's going to be filled with something that we call an electrolyte. This is probably a term you've never heard before, an electrolyte. What is an electrolyte? Electrolytes are basically a liquid or solution that contains an ionic compound. So it's a liquid or solution, so something that's dissolved in a liquid, right? Liquid or solution that contains an ionic compound. All right? Remember, ionic compounds are formed through ionic bonding. So, liquid or solution that contains an ionic compound. I said liquid or solution, right? That's because there's two different ways the electrolyte could be made. Option number one, I'll go back to white now. Option number one is the compound is soluble. So the ionic compound is soluble. So soluble means it can dissolve, right? The compound is soluble. If it is soluble, right, we can just dissolve in water. Dissolve in water. Right? Because if you remember, in order to conduct electricity, so electrolyte is using electricity, right? So it's going to have to conduct electricity. To conduct electricity, you need either one of two things. One is delocalized electrons, but that's only for metal, so we can't really use that for this case. But the second option is free ions, so ions that are free to move about. In order for ions to be free to move about, you need to have liquids. Liquids because the particles can move, or a solution because that's also technically a liquid, right? If you don't remember why this happens, watch my previous video on electricity conduction and why metals can conduct electricity, but non-metals usually can't. So the compound is soluble, so it's going to dissolve in water, so we're going to make it a liquid, right? So if it's a liquid, it's going to form, so it's dissolved in water specifically, so it's going to form an aqueous solution. If you don't know what an aqueous solution is, it's when the solvent is water. So when the thing being dissolved, the liquid that the thing dissolves in is water. So it's going to form an aqueous solution, and so the ions can move. So that electricity can be, ions are free, okay? Ions are free. That means electricity can be conducted. Ions are free, and this is then the electrolyte. This is one way electrolytes can be made with the ionic compound. So if the ionic compound is soluble. But if it is insoluble, right, so it cannot dissolve in water, then you need a different method. What you can do is you can melt it. Even if it's insoluble, you can melt the ionic compound, right? So we can melt the ionic compound, and what would then happen is we'd get a molten liquid. And remember, it needs to be either a liquid or a solution. So a molten liquid and free ions. Free ions, so electricity can be conducted, and that is another way to get our electrolyte. So that there's two ways to do this. Now in our case with lead bromide, Lead bromide is insoluble. Lead bromide. So we can't melt it in water because it won't dissolve. It will stay as a solid, which means electricity can't conduct. So we're going to have to melt it insoluble. So we're going to have to melt the lead bromide into molten lead bromide. So we're going to have molten lead bromide, and then we'll have free ions, and that'll be the electrolyte. So in our case, the electrolyte will be molten lead bromide. Now, this isn't electrolysis. We're not done yet. We're not even close to done. How electrolysis is, we're going to have to deliver our electricity, right? So we use something that looks like this. These two sticks, you could call them, they're called electrodes. Electrodes. And the electrodes are basically just solid conductors. So electrodes, let me erase this. Electrodes, they are solid conductors of electricity. And they're typically made up of two different materials. It's either metal, because metals can conduct electricity, right? It's either metal or it's carbon. Right? It's either made of carbon or metal. And these electrodes, right? They have two different charges. One side is negative, and the negative side is called a cathode. The positive side is called an anode. Now this is really easy to mix up because cations are positive ions, cations are negative ions, and anions are positive ions. Cations are positive ions and anions are negative ions, right? And here it's the opposite. These cathodes, these are the negatives, and these anodes, right? These anodes are the positives, so it can really get confusing. So just watch out for that. And connecting these two machines over here, I actually made a mistake. We have a battery. I drew it the wrong way. We have a battery, and I'll tell you what the battery does in just a second. So we have our cathode, negative, and the anode, positive, on the right hand side. And we have molten lead bromide here. Alright, so then, how exactly does this work? Well, we have our molten lead bromide, right? And if we look at the equation for a molten lead bromide, it's PbBr2. Pb is the lead, and bromide, this is the bromine. Remember, when they react, it turns into lead bromide. You need to know the charges for this. The charge for lead is a 2+ charge. I'll write that in blue. So lead has a 2+ charge. That was a bit bad. Lead will have a 2+ charge, and bromine will have a 1- charge. Now this is quite confusing, because if you are smart, you'll know, if you look at the periodic table for lead and bromine, you'll see that lead is in group 4 and bromine is in group 7. Now these are ionic compounds, right? So they formed ionic bonds. And ionic bonds, the metals give the non-metals electricity, right? Not electricity, electrons, right? Because they want to lose electrons. Watch my video on ionic bonding if you haven't done so already. So lead will have 4 electrons because it's in group 4, right? No, because lead, if you look at the periodic table, right? We have group 1 and group 2, and then here we have like our staircase, and these are our non-metals. But here we have our transition metals. Transition metals. These transition metals, they don't form a specific charge. The thing about transition metals is they have varying charges, and it's dependent on their oxidation state. You do not need to know this for your GCSEs. This is A-level chemistry. So all we can really do at this point is just memorize the different charges. I've thought about this, but there's really no way. You just have to memorize it. Usually, if it's a metal or a non-metal, in group 4, it would have 4 electrons in its outermost shell, valence shell. But because lead is a transition metal, it does not have a specific stuck charge. Therefore, it's not going to form a lead 4+ charge. It's going to form lead 2+ and bromine minus. That's just something that you'll have to memorize, unfortunately. So instead of our molten lead bromide, let's fill this out with the different charges we're going to have in here. We're going to have our Pb 2 plus and our bromine minus. Obviously, we're going to have a lot more of this, so this is going to be filled with Pb2 plus and etc. And these are molten, so all these particles can move about. Then what happens? Well, it's kind of obvious, right? Magnets. The bromine's going to stick to the positive, and the lead is going to stick to the negative, the cathode. It's kind of like magnets, right? Positive sticks to negative, opposites attract, basically. So these bromines, they attract to the anode, the positive. Remember, anode is positive. And what happens here is that they lose their electrons. So what happens is they become discharged. So they lose their electrons to just become neutral bromine. Once it becomes neutral bromine, they pair up. Two bromines pair up together, and they go up into the atmosphere and become bromine gas. And they pair up together like that. That's what happens to the bromine during electrolysis. And with the lead also gets discharged, so the Pb, right? Pb2 plus, it just becomes Pb, discharge, it becomes neutral. And it just falls down. Lead just falls down. So lead, once it becomes discharged, it just becomes neutral lead, and it just falls down, making a layer of lead on the floor. Solid lead, by the way. Pure lead. And bromine, pure bromine in the atmosphere, because it loses its electrons and it becomes, the two bromines pair up together and they become gas state. Now, how exactly does this discharging happen? Well, let's look at this in a bit more detail. The bromines all have a negative charge, right? Bromine minus. Well, they go to the anode and they deposit their electrons. So all the electrons get deposited at the anode, and they just become pure bromine pairs, and they float off in gas states. Now this anode side has a lot of electrons. Now this is the role of the battery. The battery carries this charge, right? So the battery carries the charge over to the cathode, and Pb, the lead has a 2 plus charge, right? So it means that the lead lost 2 electrons. That's why it has a 2 plus charge. Well, it's going to receive these electrons that the bromines dropped off, and these charges are going to cancel out, and they become pure bromine, and they just fall on the floor. So basically, if I draw a new diagram, these electrons are dropped off by the bromines. It's the battery has the power, right? So it moves the electrons. It gives the energy for these electrons to move to the positive, to the negative side, sorry, to the negative cathode side. And the lead, Pb, 2 plus, they receive these electrons, cancel out, and they become pure lead, and they just fall down on the floor. And the bromines form pairs, and they float off into the atmosphere. That is essentially what it is. That's the concept of electrolysis. It's using electricity to break up, to split apart ionic compounds. In the case of lead bromide, it's an insoluble solution, so we melt it. And then the bromines have a negative charge, so it attracts the positive anodes. It drops off their electrons. It becomes a pair of bromine gas molecules, and they float off. These electrons are carried by the battery, so the battery provides the energy. That's why we need the battery here. And it goes to the negative cathode. The lead 2 plus, it receives these electrons that the bromines have deposited. These 2 plus charge is going to get cancelled out, forming just pure bromine on the bottom that sinks down. That is essentially electrolysis. And in this case, more specifically, we've looked at the electrolysis of lead bromide. But the essential concept will be the same for any compound of ionic compound. It'll just be electrons, and electrons being sent in the anode, move to the cathode, and just forming different types of output solutions, products. Thanks for watching this one on electrolysis. I hope you enjoyed it, and thanks for watching.